Welcome you again to today's class. Any doubts you have? Nothing, right? So, okay. Don't have any doubts. So let us start from where we left yesterday. So what we were doing yesterday was a result about testing composite hypothesis, basically one-sided composite hypothesis. So the result which we stated last time is of the following type. So what you have is X has a PDF, let us say F, which belongs to the family P, which is collection of all those F theta. So that theta belongs to theta. The theta is a subset of R, so you have one parameter. Huh? No, the last one. I'm just trying to repeat it. This has MLR in TX. I have to consider testing H naught at theta less than or equal to theta naught against theta greater than theta naught. Right? The first part said there exists a UMP alpha test, which is of the type phi star X is equal to 1. Of course, here, since you have MLR and under alternative, you have a larger values of theta, so you would reject for larger values of t. So if t is greater than c, 0, sorry, gamma, if t is equal to c, and 0, if t less than c. And how do you choose this c and gamma? So that theta phi star theta naught is same as alpha. Right? That is how you choose c and gamma, where c and gamma between 0 and 1 are such that this happens. Right? So that was the first part. The second part we said was beta phi star theta is strictly increasing for all thetas for which beta phi star theta is between 0 and 1. Right? So in the set where beta phi star theta is between 0 and 1, beta phi star theta is strictly increasing, whether your theta is in the alternative hypothesis or the null hypothesis. Doesn't matter. Then we also saw that b star phi star theta or phi star minimizes beta phi theta. Or for any theta less than theta naught, beta phi star theta, or phi star minimizes beta phi theta. Now note that theta less than theta naught, that means under alternative hypothesis, sorry, under null hypothesis, what is a beta phi theta? Is a probability of type 1 error, because beta phi theta is probability of rejecting H naught. So probability of rejecting H naught when theta is less than theta naught, that means H naught is true. So there is a type 1 error. So it says this test has additional beauty that this also minimizes the type 1 error among all tests for which size is exactly alpha. Right? Phi star minimizes by phi theta, that is a probability of type 1 error. Among all tests phi satisfying beta phi theta naught is equal to alpha. D for any theta 1 belonging to theta phi star is UMP alpha star test for testing H naught that theta less than or equal to theta 1 versus H1 that theta greater than theta 1 with alpha star given by E theta 1 phi star. Right. So they all are just straightforward proofs. First and two I have proved. C is very straightforward to prove. So for C, what you do is you consider the reverse of this hypothesis. Right? Consider testing H naught theta less than theta naught against H1 that theta greater than theta naught. Right? What would be, and change my label alpha to be 1 minus alpha. Is that okay? And change my alpha to be 1 minus alpha. So what is the 1 minus alpha level test for dual of that hypothesis? It will be exactly same that T less than C and T greater than C, except that now C is chosen such that E theta naught of that test is 1 minus alpha. But that is same as considering 1 minus phi. So that means 1 minus phi would be the UMP 1 minus alpha test for testing that. Now the type 1 error and type 2 error are interchanged. So here the power would be maximum. And power of this test would be same as the probability of type 1 error of the other test. So that is the whole idea, right? Is that clear or? Is that clear or not? Because what you have to do, you have to show that, for example, for any theta less than theta naught. So let us take theta 1 less than theta naught. Right? Let us consider theta 1. So I'll just give you an idea of the proof. So this is C. Let us consider H naught theta is equal to theta naught. So first let theta 1 is less than theta naught, right? Okay. I have to show that beta phi star theta 1 is smaller than beta phi theta for any test phi for which beta phi theta naught is. Okay. Let us consider H naught theta is equal to theta 0 against H1 that theta is equal to theta 1. Right? Is that okay? So what is the UMP alpha test over here? Exactly the same, because if T less than C and all that, right? Phi naught, let me call, or phi double star. If T is less than K, gamma, if T is equal to K, and 0, if T is greater than T. And how do you choose this K? K are chosen such that beta double phi star theta naught is same as, yeah, I'm running UMP 1 minus alpha test. Because I'm considering a dual, so I'm considering 1 minus. So beta phi star theta naught is 1 minus alpha. Is that okay? Now let us consider 1 minus phi star. The phi star test was over here, and I consider 1 minus phi star. So what would be 1 minus phi star test? One, if T is less than C. 1 minus gamma. Here you put gamma star, right? Gamma star doesn't matter. 1 minus gamma if T is equal to C, and 0 if T greater than C. Is that okay? What would be beta 1 minus phi star theta naught? T less than C, na? 1 minus phi star, na? 1 minus 0. When it is T less than C. That is a phi double star. That is another test, right? That is a UMP for that. I'm comparing that with 1 minus phi star of this test. Because I'm trying to show that 1 minus phi star is same as phi double star. Basically, that is what I'm trying to show, right? What is the beta 1 minus phi star theta naught? It is expected value of theta naught of 1 minus phi star by definition. But E theta naught phi star, because here was alpha. So this is same as 1 minus alpha. So what does this suggest? The form are same and C and gamma, everything is uniquely determined. So that means your C would be same as that K. 1 minus gamma would be same as exactly gamma star. So that means the two tests would be the same. So this implies that 1 minus phi star would be same as phi double star. But phi star is UMP alpha, right? Phi star. So let phi be. So here I told let phi be any test such that beta phi theta naught is equal to 1. Test. Actually, here since I am considering two hypotheses simultaneously, I have to clarify H naught theta less than or equal to theta naught versus H1 theta. Is that okay? What does that mean? This implies that beta of 1 minus phi theta naught would be how much? Expected value of 1 minus phi under theta naught, which is 1 minus alpha, right? You see, beta phi is nothing but expected value of that test. So it would be expected value of 1 minus phi under theta naught. Under theta naught, expected phi is alpha. So it would be 1 minus alpha. Now, if phi is a test for this, if phi is a test, 1 minus phi is also a test. So that means this is a test. So 1 minus phi I can consider a test for. So 1 minus phi is a test for star, for testing hypothesis star. Because only definition of phi is it should be based on a sample and it should be between 0 to 1. So if phi is between 0 to 1, 1 minus phi is also between 0 to 1. So it is a proper test. Beta 1 minus phi theta naught is exactly 1 minus alpha. And this test is most powerful of size alpha. So that means this implies that beta of phi double star theta 1 would be bigger than or equal to beta of 1 minus phi of theta 1. Is that okay? Because phi double star is most powerful. So its power is at theta is equal to theta 1. But beta, what is the beta of phi double star? That is beta 1 minus phi theta 1, which is nothing but 1 minus beta phi theta 1. Not exactly this. Yeah, that would be 1. So yeah, so that now proves, right? Because this is equivalent to saying that expected value of phi double star is bigger than or equal to expected value of 1 minus phi. But phi double star is same as 1 minus phi. Phi double star is nothing but 1 minus phi. So expected value of 1 minus phi star is bigger than or equal to E theta 1 of 1 minus phi. So that means E theta 1 of phi would be less than or equal to E theta 1 of phi star. Is that okay? So that means E theta 1 of phi would be greater than or equal to E theta 1 of phi star. which is probability of type 1 error for that problem, the original problem. Under actually, yeah, of phi would be bigger than or equal to probability of type 1 error of the idea is very simple. Basically, one is a dual of the other, right? If phi star would be a UMP alpha test for one thing, 1 minus phi star would be UMP alpha for the other kind of a thing. Is that okay? So if you have taken the level to the maximum one, it will also minimize the probability of type 1 error. So that's another beauty of this course, with this test. Now the fourth, you can prove exactly in the same line. For any phi star is UMP alpha test for, because how do you prove it? What would be a UMP alpha test for this case? Because under alternative, you're rejecting for large. So UMP alpha test would be 1 if t is greater than k, gamma if t is equal to k, and 0 if t is less than k. I want my level to be alpha star. So that means I want E theta 1 of phi naught to be alpha star. But E theta 1 of this itself is alpha star. So that means that test would be same as this test, because the form is same and you want that E theta 1 of phi should be same as alpha star. Is that clear? Or you see, idea is very simple. First of all, note that whenever you are considering hypothesis, you should be clear about what should be the structure of the test. Now, once structure is determined, that means 1 if t less than k or 1 if t is less than k, then it is a matter of determining those constants. And those constants are uniquely determined, subject to the condition that beta phi theta is not equal to alpha. Now I'm saying, suppose you have to consider this. Theta less than or equal to 1, again theta greater than 1. What is the UMP alpha star test? Let me call this as phi double naught x 1. Under H naught, you are rejecting for large, so t is greater than, let us say, d. Gamma, let us say, double star if t is equal to d, and 0 if t less than d. Is that okay? And how do you determine d? Says that beta phi double naught theta, which is E theta naught phi naught of x, basically, which is this, which is probability that under theta naught t is greater than d plus gamma double star probability under theta naught t is equal to d should be same as, sorry, theta 1, right? Because you're testing under theta 1, right? Because this turning point is theta 1. So that is where you want alpha is equal to alpha star. Is that okay? Let us look at what is happening for this test. This test is exactly of that type. And what is alpha star? Structure is same, E theta 1 of phi star, which matches with this. So what does that mean? That means phi star has to be same as phi double naught. So the same test is UMP alpha with level now at whatever is the value of this test at theta is equal to theta 1. Is that okay? Because the structure remains the same, right? Because of more likelihood ratio property. Okay, so this tells you a lot of things about one-sided test. Of course, if you're dealing with a hypothesis, so let me write down this as another theorem. So I make it here, theta greater than or equal to theta naught, theta less than theta naught. Then there exists a UMP alpha test, t less than c, t greater than c, where c and gamma are such that beta phi star theta naught is alpha. Exactly the same proof works over here. So this proves, this tells you how to find uniformly most powerful tests in situations where you have a monotone likelihood ratio property. One strong family of distributions which has a monotone likelihood ratio property is the one parameter exponential family. So let's try to see, because your negative binomial, Poisson, binomial, geometric, normal, gamma, exponential, everything is covered under exponential. So let's try to see what happens under the exponential, what happens under the exponential family. So let me write down this as a corollary. You understand the meaning of corollary or not? You understand the difference between lemma, corollary, theorem? Yeah? Corollary comes? Why lemma cannot come after? Yeah, so what happens is corollary could be one of the particular consequences of a main theorem. So theorem is the main result, right? Which is contains whatever is possible is there is contained in a theorem. But if you want to emphasize on a particular case, that can come as a corollary. And lemma is something which is a tool which you are trying to develop to prove the theorem, right? So lemmas or propositions, they are basically tools. So this corollary is a consequence of the last theorem, which I'm going to write it down. So suppose that X has PDF f theta x, which is e to power eta theta dx minus xi theta into hx. X belongs to some space chi where hx is positive. Theta belonging to theta, which is a subset of one. And I assume that eta theta is increasing. Now we have seen that if it is an increasing function of theta, then f theta x has MLR in Tx, because you can look at f theta 2x upon f theta 1x. That would be e to power eta theta 2 minus eta theta 1 into Tx. And since eta is increasing, eta theta 2 minus eta theta 1 will be positive, so it will be increasing in T. So this we have already seen. This has MLR. Right, Tx, let me call this as just T. So if I have to consider Ump alpha test for H naught where theta less than, I can put for greater than also, theta naught, versus H1 that theta is greater than, theta less than. So in this case, alternative is theta less than theta naught. So whatever is in the bracket is for the other case. Is phi star T or phi star X, let me call it, 1 if T is greater than in outside the bracket hypothesis. That means when theta less than equal to theta naught, against theta less than greater than theta naught, and less than the other situation. C gamma if T is equal to C in both the cases, and 0 if T is less than or greater than C, where C and gamma are such that beta phi star theta naught, right, the turning point, is alpha. What does that mean? That means E theta naught phi star t phi star x is same as alpha, which is equivalent to saying that probability under theta naught t is greater than or less than c plus gamma times probability under theta naught t is equal to c. Is that okay? So all exponential families, you don't have to do anything. You can do this. Now note that one may say that there may be situation where eta theta may be a decreasing function. But it doesn't matter if eta theta is a decreasing function, in place of t, you take it as minus t. And you write down as e to the power minus t and minus of eta. So if eta is decreasing, minus eta would be increased. So in place of t, you get minus t. So you'll get minus t greater than c. So the inequalities would just get interchanged, right? And which matches with your intuition that if eta theta is decreasing, it doesn't have MLR in t, it has MLR in minus t. Is that okay? Okay, so let's quickly do this normal example. X1, X2, Xn are IID. Normal, let us say theta, sigma naught square. Theta belongs to theta, and sigma naught is known. H naught, theta naught is a fixed constant, right? So suppose theta naught belonging to R is fixed. Right? And suppose you have to test H naught that theta less than or equal to theta naught against H1 that theta greater than theta. Now this normal belongs to exponential family. What is the eta theta over here? We have seen last time. Theta by sigma naught square, right? Or m theta by sigma naught square. Whatever you can, because you can play around, right? Constant you can always multiply and then t becomes. So if you're taking, and you can pass on over there, so you can take t also to be an x bar, right? So tx is x bar, so it has MLR in x bar, right? That we have seen. So what is a UMP alpha test? Phi star x, which is 1, if x bar is greater than c. You see, I need not consider gamma because that would be under x bar is equal to c. And normal being a continuous distribution, probability x bar is equal to c would be 0. So I don't have to care about that. So 0 if x bar is less than c. Where c is such that beta phi star theta naught, because turning point is theta naught, is same as E theta naught of phi star, which is same as probability under theta naught that x bar is greater than c is alpha. Is that okay? So you have to choose c so that this is happens. That means probability theta naught less than or equal to c should be same as 1 minus alpha. But when theta is equal to theta naught, x bar has normal theta naught and sigma naught square by n. So this is equivalent to saying that probability theta naught less than or equal to c would be 1 minus alpha. So that means phi of root n c minus theta naught by sigma naught is 1 minus alpha. Just I've written down this. The same as probability theta naught, probability under theta naught, x bar less than or equal to c is 1 minus alpha. What does that mean? That means c is nothing but phi inverse sigma naught, c is same as theta naught, plus phi inverse of 1 minus alpha sigma naught by root L. Now try to activate your statistical mind now, because this is some very mathematical equation. This should tell you, you should be able to infer from this some mathematical equation what is happening. You see, if you give it to a layman, he says ki bhai theta less than or equal to theta naught against theta greater than theta naught has to be tested. So he says, by you observe sample mean, if sample mean is bigger than theta naught, you always reject H naught. Otherwise, you do not reject. That's a valid test. But it may not be uniform. What is the probability of type 1 error of this? Such a test? I reject H naught if x bar greater than theta naught, 0 otherwise. That is a very naive test, if I call it, right? Because you see, you say that, look, sample mean would be very close to population mean. So if sample mean itself is bigger than theta naught, that gives me evidence that population mean is bigger than theta naught. So I'll reject H naught. That looks like a intuitive test. But my question is, as a statistician, you should be enabled to, you should be in a position to tell something about this test. Somebody comes to you and says, look, I'll use this test. Tell me what are the problems with this test. So the first thing we'll say, let us look at what is the probability of type 1 error. Probability of type 1 error means probability under theta naught that x bar is bigger than theta naught, right? That is half. So probability of type 1 error is half. So that is as good as not using data at all. You can toss a coin and say, ki bhai, although to a layman it may look like correct. So how do you justify this statistically? The way to justify statistically is, look, this sample we have observed, it, although it is a representative of the population, it has a noise, because finally it is a random sample. So assuming that x bar would be exactly theta naught would be too much to expect from the sample. Because there will be some noise which a statistician has to take care of. If he feels that his data is noise free, then he should better not be a statistician. Then he is believing in a perfect world, which is not the case. And that is what is happening over here. The statistician says, look, don't reject when x bar is greater than c, greater than theta naught. Take some margin and reject H naught only when x bar is bigger than theta naught for a certain quantity. Because for me, probability of type 1 error is very serious. So if the other fellow who came up with very intelligent idea that reject H naught if x bar greater than theta naught, he's taking too much risk with the probability of type 1 error. Because if there is a noise in the data which is inherent, then that could make your life miserable, right? And that is what is happening. Half will be the probability of type 1 error. Another way to notice it, and that is what I have been trying to encourage you, whenever you see these equations, try to infer as much information as you can. So what was the problem with the original test? Because, so I gave an explanation as a statistician. Because expecting that your data would be noise-free would be a foolishness to assume, right? Because the data is random, that itself says that there is a noise in it. But then somebody said, look, if I make my sample size very large, the noise should decrease. And if I have exhausted my whole population, there should not be any noise. And then the other fellow says, in that situation, how my test would perform. then my statistician's answer would be fine. Then there is no noise in data, then what you are saying is fine, your X bar captures the true mean, then your test is perfectly fine. And that is what is exactly happening over here. As n goes to infinity, what is this constant C happening? So the reason why I'm trying to provoke you to think in this way is a lot of times you can just through these observations, you can make sure whether your test makes sense or does not make sense. For example, if this test had to make sense as n goes to infinity, this should be similar to the test which rejects H naught if X bar is greater than theta naught, right? Is that okay? Okay. So let me just take few more examples. Okay. What will be the UMP alpha test for theta is equal to theta naught against theta greater than theta naught? So my hypothesis I change. My null hypothesis becomes a simple hypothesis. And H1 what would be UMP alpha test? Same, right? Because it maximizes the power. So as long as that test has a level alpha, which is the case because that test has a level alpha, it has a size alpha in that. So that with the same test is UMP alpha. We can write down note. Phi star is also UMP alpha for testing. All right. Okay. Now theta less than or equal to theta you can consider. Similarly, let us consider a binomial example. IID binomial and theta. Theta belongs to theta, which is 0, 1. N is known. Number of trials are known. Right. So again, I consider theta naught belonging to 0, 1 is fixed. I consider H naught, let us say theta greater than or equal to theta naught against theta less than theta naught. Does this have a MLR? Binomial we have seen last time, right? It again belongs to exponential family. We rate eta theta as log of theta upon 1 minus theta, right? And what would be your T? X bar summation xi. Now in this case, I'll take summation xi because I know the distribution of summation xi, right? So has MLR in Tx or X bar, which you know has a binomial and theta distribution. In this case, alternative is smaller values of theta. So you reject for smaller values of T. So UMP alpha test phi star x is equal to 1 if T is less than C, gamma is equal to C, 0 if T greater than C, where C and gamma belonging to 0, 1 are such that beta phi star theta naught. What would be beta phi star theta naught? Probability under theta naught T less than C plus gamma times probability under theta naught T is equal to C is same as alpha. Is it okay? Now I can always assume C to be an integer because T only takes integer values. So that means summation j is equal to 0 to C minus 1 right? Because under theta naught, T has binomial and theta naught, right? So probability under theta naught T less than C means J is equal to 0 to C minus 1 binomial, and choose J theta naught to power J 1 minus theta naught to power n minus J. Where? No, binomial n. Oh, each of them is binomial n, right? Yeah. So actually, no, I should not take binomial 1 theta. You can take it, right? Or if you want, you can take m theta, right? Sample size and the parameters will be different, right? N is not. Yeah. So binomial nm theta. So it would be nm choose j theta naught to power j 1 minus theta naught n minus j plus gamma times probability T is equal to C. That means nm choose C theta naught to power C 1 minus theta naught to power nm minus C should be same as alpha. So you can start with the value of C as 0. Then the first sum doesn't contribute anything. Then you see whether there is a gamma such that that happens or not. So what I do is note that this quantity has to be less than alpha, right? And I know that this is a increasing function of C. So I start from the smallest value of C, which is 0, and I keep on seeing and see until what point it remains less than alpha. The moment it crosses alpha, I come to one step backward, because that is the C it should work. I take that C and then I can determine gamma by doing that. Is that okay? Similarly, you can do for Poisson. H naught and theta naught is greater than 0 is fixed quantity. You're testing H naught theta less than or equal to theta 0. Now you have seen that Poisson also has MLR, and it has MLR in symmetry Xi. Which makes sense because theta is the mean, so it should have MLR in the sample mean, right? Sample mean is equal to summation Xi. They differ just by a constant. So what would be Ump alpha test? One, if under H naught larger values of theta, so T greater than C, gamma if T is equal to C, 0 if T is less than C. And how do you choose gamma and C? Beta phi star theta naught is alpha. That means probability under theta naught T greater than C plus gamma times probability under theta naught T is equal to C is alpha. You can consider C to be an integer, so it becomes J is equal to C plus 1 to infinity. Now note that under theta is equal to theta naught, T has Poisson and theta naught, right? Because you know that Poisson has a reproductive property. So J is equal to C plus 1 to infinity e to power minus n theta naught to power j by factorial j plus gamma times e to power minus n theta naught to power c by factorial c. You can look at Poisson distribution table and you can just determine that. So these all were examples of exponential family. Now let's consider one example of non-exponential family, which is a uniform zero theta or exponential with location parameter theta. So x1, x2, xn ID uniform zero theta. Theta naught is greater than 0 is a fixed quantity. H naught theta less than or equal to theta naught against H1 that theta greater than theta. Does uniform has MLR? We saw it in the class, right? It has MLR in Xn maximum, right? You know that it has MLR, right? We saw that f theta 1 upon f theta naught x. In the beginning, it is a fixed quantity. What would be that? 1 upon theta naught to power n upon theta 1 to power n until t less than between 0 to theta 1, 0 to theta naught, and beyond theta naught to theta 1, it becomes infinity because f theta naught becomes 0. So from a fixed quantity, it goes to infinity, so it is increasing. So it has MLR T is equal to x. What is the UMP alpha test? Under H1 large value, so T greater than C. T is equal to C, I need not bother. Because it will be gamma if T is equal to C. But T is equal to C, probability is 0. And what you want is beta phi star theta naught is alpha. What does that mean? That means probability under theta naught that xn is greater than C is alpha. Or xn less than or equal to C should be 1 minus alpha. The density of xn, you know, n t to power n, so that means C by theta naught to power n is alpha. What does that mean? That means C is nothing but theta naught times alpha to power 1 by n. Is that okay? Is this the only UMP alpha test? Can you get another UMP alpha test? Can you propose another UMP alpha test? Just recall our discussion when we were testing theta is equal to theta naught against theta is equal to theta 1 bigger than theta naught. In the uniform case, we had seen there are more than one UMP alpha test. Right? And certain UMP alpha tests do not depend on the choice of theta 1. So they would be again UMP alpha test for, so another UMP alpha test in this case. phi double star is equal to 1 if xn is greater than theta naught and alpha. So here, UMP alpha test is not unique. Note that theorem only tells you there exists one such test and it gives you a form of that test. So it says there is a test of this type. It doesn't say that there is no other test. There can be other tests. And in this case, how do you prove that this would be UMP alpha? Anyone? How do you prove that this is a UMP alpha? This is also. See, one way is you find out the power of that test. And so that power is exactly same as this one. And its label is alpha. Label is alpha is not difficult because label is nothing but 1 under theta naught xn greater than theta, which is 0. Under theta naught probability that xn greater than theta plus alpha times probability under theta naught xn less than or equal to theta naught, which is 1. So it is exactly alpha. Label is alpha. And its power would be exactly same as that test. But that is okay. That is okay once you are asked to prove that this is a UMP alpha test. But suppose it was not given and you had to ask, and you were asked to find another UMP alpha test. How do you do this? From the first principle. Apply the Neyman-Pearson lemma for testing theta is equal to theta naught against theta is equal to theta 1, where theta 1 is bigger than theta naught. You find, the way I did it in one of the lectures, you find that this is one of the tests. You can choose a C such that this happens. And this test does not depend on alpha, that theta 1 which you have chosen. So certainly this would be uniformly most powerful for theta is equal to theta naught against theta greater than theta naught. So the only thing you need to show is it is of level alpha for theta less than or equal to theta naught. But this has MLR in xn. And what is a phi star? It is an increasing function of theta naught or decreasing function of theta naught? It is increasing because from initially from xn less than or equal to theta naught, it is alpha, which is between 0 to 1, and from that it goes to 1. So it is an increasing function. And you know that it has MLR in xn, so its expected value would be increasing in theta. So that means beta phi double star theta would be increasing in theta. But beta double phi star theta naught we have seen is alpha. So that means beta phi double star theta would be less than or equal to alpha for all theta less than theta naught. So it satisfies level condition also. So it would be uniformly most powerful for theta less than or equal to theta naught also against theta greater than theta. Is that clear? So tomorrow we'll have a tutorial. There are two assignments lying. One is on these variance inequalities, mainly the Rao-Kramer inequality and all. And the second one is again that hypothesis testing. So we can discuss those tomorrow. Right. Oh, it is not. Okay, I'll do it today. Both the lectures I'll upload.